So today we're going to be looking at a stoichiometry question that goes a bit beyond just the mole concept. So we're looking at a single replacement reaction. We have iron 3 oxide reacting with pure aluminum to form pure iron with aluminum oxide. So in this single replacement reaction, the aluminum is replacing the iron because aluminum is higher up on the activity series than iron is. So the question we are given is, how many grams of Fe2O3 are needed to make 17 moles of pure iron using excess aluminum? So what we want to think is, how is this question different from the question we saw in the previous video? This question is different because it is asking us to find grams. All right. Instead of finding moles like we did in the previous video, we are trying to find grams, but we are still going to be using the mole ratio. Additionally, we're given the information that there is excess aluminum. All right. The fact that there's excess aluminum means that there is as much aluminum as we need. All right. There will be more than what we need. So imagine that you're baking a cake and you have just so much sugar at home that sugar is in excess. No matter how much cake you want to make, there is enough sugar for you to use. So no matter what recipe you use, there's always enough sugar. In this question, no matter how much iron we want to make or no matter how much iron 3 oxide we're going to start with, there's always enough aluminum to react because it's in excess. Anytime you see this in a question, excess amount of any reactant, that means that there's more than enough of it, so don't worry about it for the remainder of the question. We're just going to stop worrying about aluminum. So the first thing we want to do is figure out the mole ratio, and we'll handle the grams after that. We are given 17 moles of iron. All right, that's what the question is giving us. And what we are being asked to find is the number of grams of iron 3 oxide, formula Fe2O3. So we're going to use the mole ratio to figure out the moles of iron 3 oxide, Fe2O3, and then we will figure out the grams once we know the moles of iron 3 oxide. So we'll do that in just a second. We are multiplying the given amount of iron, which is 17 moles, by the mole ratio. Now, the mole ratio is 1 mole of iron 3 oxide is equal to 2 moles of iron. So it's important that we put what is given on the bottom in the mole ratio. Okay, so 2 moles of iron is going to go on the bottom. And what we want to find, which is ultimately grams of iron 3 oxide, but we're going to have to start with moles first and then convert that to grams, is going to be, from the mole ratio, 1 mole of iron 3 oxide. Again, formula Fe2O3. So the math I'm doing is 17 moles of iron times 1 mole of iron 3 oxide divided by 2 moles of iron. My moles iron will cancel because I will have them on top and on bottom, and I'm left with moles of iron 3 oxide, and mathematically 17 times 1 over 2 is equal to 8.5 moles of iron 3 oxide. So that is what we are doing. And in the next step, we're going to convert the moles of iron 3 oxide to grams of iron 3 oxide to finish the question. We need to convert from the moles of iron 3 oxide to grams, and to do that, we are going to need the molar mass of iron 3 oxide. So what we want to remember is to use our periodic tables. Okay, the molar mass of every individual element is on the periodic table, so make sure you have one of those while you are attempting these questions. The molar mass of iron is 55.8 grams per mole. If you would round that to 56, it wouldn't affect your answer on a quiz or a test, so don't worry about that. But I'm going to keep it as 55.8. And the molar mass of oxygen is 16 grams per mole. You might want to put 15.9, 15.99, 15.999. Again, not going to impact, the credit you would receive for a question like this. As long as you are deciding on a molar mass, you're going to be getting credit. Now, in the chemical formula for iron 3 oxide, there are 2 iron atoms and 3 oxygen atoms. So it's important when we add up the mass of all the iron and the mass of all of the oxygen that we multiply the molar mass for each individual element by its subscript. So I'm going to be doing 55.8 times 2 plus 16 times 3, and that is going to equal a total molar mass for iron 3 oxide of 159.6 grams per mole. I did this without a calculator. You would be entitled to a calculator though, so do not worry about that. But just remember, keep your periodic table with you when you're doing these questions, because whenever you're looking for a molar mass, you're going straight to the periodic table for that. And just make sure you add everything up, you multiply each individual element by its subscript, and you'll be good to go. For us, we are working with 159.6 grams per mole for iron 3 oxide, Fe2O3. And if you remember, we have 8.5 moles of iron 3 oxide. So now we're going to figure out how many grams of iron 3 oxide we have. We are doing moles times molar mass to find the mass. Okay, you are multiplying, so just remember, moles times molar mass equals mass. And we have 8.5 moles of the iron 3 oxide times its molar mass, 159.6 grams per mole. And we are going to get a final answer of 1,357 grams of iron 3 oxide. I actually got 1,356.6 and I rounded it. Alright, again, you do not have to worry about the sig figs that much in this unit, but in this step I'm doing moles times molar mass. We already established it's 8.5 moles from using the mole ratio. We calculated the molar mass using a periodic table. And we are doing moles times molar mass. We're getting mass, 1,357 grams iron 3 oxide. The question asked us to find grams of iron 3 oxide, so we know to stop at this step. Alright, so we found what we were looking for. We did 2 steps to finish this question, and we're done. We should feel good. So in the next part, I'm going to show you what it would all look like if you were to have used a bridge, but you could just do this as 2 separate steps. So here's what the bridge should look like. You want to put the moles of what you're given in the first part of the bridge. In the second part of the bridge, you want to put the mole ratio. So you want to put the coefficient for what you're looking to find on the top, and the coefficient for what you are given on the bottom. And in the third part of the bridge, you want to put the molar mass, which means you want to put the grams of what you're looking to find on top per the number of moles of what you're looking to find. And with the molar mass, since when the number you calculate from the periodic table, since it's grams per mole, it's technically grams per 1 mole. So anytime you put molar mass into a conversion bridge, that moles part should always be equal to 1 mole, and that grams part is whatever number you're getting from the periodic table, keeping in mind that you need to multiply for the subscripts for each individual element. In our bridge, we are now putting in the actual numbers, so it's 17 moles of iron times 1 mole of iron 3 oxide divided by 2 moles of iron times 159.6 grams of iron 3 oxide divided by 1 mole of iron 3 oxide. So, as we see from left to right, since moles of iron are on top and on bottom, they will cancel out. Since moles of iron 3 oxide are on top and on bottom, they will cancel out. And our final answer will be in grams of iron 3 oxide. Now, 17 times 1 times 159.6 divided by 2 divided by 1 is 1,357 grams of iron 3 oxide. So here's what your bridge would look like. The bridge method is a nice simple way of doing the math. It's a way to do all of the steps in one shot as opposed to doing two separate steps, going from moles of iron to moles of iron 3 oxide and then going from moles of iron 3 oxide to grams of iron 3 oxide. And this is definitely a much more reasonable question than the previous question in the previous video, because in a laboratory setting, a chemist needs to actually measure out the grams of any reactant. Alright, you can't just measure the moles of any reactant. We don't have any device where you're going to put something on it and it's going to tell you how many moles you have, but we do have scales. They will measure out the mass. So anytime you're trying to do stoichiometry in a lab setting, you're trying to make a certain amount of a product, you're going to start with these certain amounts of the reactants, and you need to measure them out on a scale, so that's going to give you a mass reading. So what we will see in the last practice question on stoichiometry before our later topics is we're going to start with grams and we are going to end with grams. Okay, so given a certain amount of grams, we're going to find a certain amount of grams. All right, but for this question, this is the bridge, nice and succinct. So I know some of you don't like the bridge method, but I highly recommend it just because it will allow you to do the questions just a little bit faster once you master it.